Hello everyone, welcome to yet another video series of measurements and instrumentation. So in today's in the past couple of video series we have discussed about the module 1 and module 2, wherein which in module 1 we have seen the in module 1 we have discussed about the measurement of voltage and current. In module 2 we have discussed about the measurement of energy and power. So in module 3 we are going to deal with the measurement of unknown EMF and measurement of current and voltage in high power applications. So the module 3 is all about potentiometers and instrumentation transformers. So now we are going to see about what is mean by potentiometer, why it is being used, where it is used, and what are its applications, and then what are its types and basic construction and working principles. So these are the topics we are going to cover in this particular module. So first let's see what is a potentiometer. As the name implies, potentiometer. So a potentiometer, potential measuring instrument. So a potentiometer is an instrument designed to measure an unknown voltage by comparing it with a known voltage. So it is like an indirect method of measurement wherein which an unknown measurement is being compared with a known already measured value. So here the measurement is voltage. So the unknown voltage is being compared with a known voltage. The known voltage may be supplied by a standard cell or any known voltage source. So we use a galvanometer for this purpose, which shows null deflections. So during null deflection it means that no current flows, so no power also being consumed. So the measurement is independent of source resistance. So a good measuring instrument should consume only less power, and also it should not exceed, or it should not consume more power, which will in turn affects the operation of the circuits. So normal operating procedure of the circuit should not be interrupted by a measuring instrument on any terms. So the measurement is independent of source resistance. Now these potentiometers, let's see what is the uses of potentiometers. So it is used extensively for calibration of voltmeter and ammeters. So these potentiometers are widely used for calibrating purposes. So they are used as a secondary standards for calibrating voltmeters and ammeters. So in voltmeters and ammeters we have certain coils which will consume some voltages during its operations. So those voltages or unknown drops will be measured using these potentiometers because they give very accurate results. So this is the basic slide by potentiometers. So this is the very basic form of a potentiometer. This we have already discussed or seen in our school experiments itself. So in school laboratories itself we will use these experiments. We would have conducted this experiment. So it consists of a uniform wire of length AB, let it be 200 centimeters. So it is connected to a battery VS and then a rheostat. So first we need to calibrate this potentiometers. For that we need a primary circuit which comprises of battery and rheostat, and then we have a secondary circuit which has an unknown EMF and a standard cell and a switch for calibration purpose, and also the switch will make the circuit between the calibration part and the unknown EMF measuring part. And we have a galvanometer for showing the null deflections, and which in turn is connected in series with a jockey, which is a sliding contact K. So how it works? At first we need to calibrate the potentiometer. So Here the switch S is connected to the calibrate point, wherein which the standard cell is connected to the wire. So by switching the circuit to the calibrate position, the sliding contact jockey K is kept at a point which will give a corresponding standard cell voltage as 1.0183. So the potentiometer is first calibrated by keeping at a spot R1, which corresponds to the voltage of the standard cell. So the equation becomes R2 by R1, which is equal to cell voltage divided by Vs. Vs is the source voltage, which we already know. So therefore we need the cell voltage. So cell voltage is equal to Vs by R1 into R2. So we know that I is equal to V by R. So Vs by R1 is the total length of the wire. So Vs by the total resistance will give the working current. So R2 is the currently kept position of the jockey, which is from A to X, as seen in the circuit, as seen in the diagram. So cell voltage is equal to working current into AX. After calibration, we have to move the switch position to the unknown operating point, wherein which the rheostat is not varied, but the switch is moved towards the unknown EMF. So the unknown DC voltage will get added to the circuit in series with the galvanometer. Then the sliding wire is moved across the variable length. So the length will be varied till the galvanometer shows 0 deflections. Let the length section be R3. So the wiper is moved till there is 0 current flows through the galvanometer. So when the condition is achieved, the voltage across the selected section R3 becomes equal to the unknown voltage. So the final step is by calculating these unknown voltage from the fraction of the length of resistance wire that was connected to the unknown voltage. So I think with this we come to the end of session 1, wherein which we have discussed about what is potentiometer, what is its uses, and how it works. We have seen a basic potentiometer form, a basic slide wire potentiometers. So in the upcoming videos we will see what are the types of potentiometers available and its construction and working principle. Stay tuned. Thank you.